This is Dr. Holt. This video is on University of Texas, the interaction type problems. I'm going to work, I think it's 3 or 4 problems here. These are problems you'll see in your homework. The first problem, I have a 54 kilogram block. It slides along the top of a 144 kilogram block with acceleration of 5 meters per second squared while horizontal force of 392 is applied. There's no friction between the 144 and the horizontal surface here, but there is friction between these two blocks. First thing I'm going to do is find the coefficient of kinetic friction. Alright, first thing I would do would draw a force diagram or Freebody diagram of this. Now note here that they're using 9.81. So what I'll have here would be, I'd have the force of gravity coming down here. I'll have my normal coming back here. So we're going to label all this. This will be the force of gravity, and this would be the Earth on the 54 kilogram. And again, all that's going to be is 54 times 9.81. Sorry, I'm so used to doing 9.8. 54 times 9.81. That's going to give me 529.74 newtons. Okay, this will be your F normal. These vector quantities too. This will be my F normal, and this normal will be the 144 onto the 54, and that would be exactly the same value. Okay, you have a 392 Newton force going this way. You'll have a frictional force going back this way, and if you can, the way you can validate that is because if you take 392 and divide it by 54, you get acceleration of 7.25. I just do the summation of force equal mass times acceleration. 392 divided by 54, my acceleration should be 7.25. I got acceleration of 5, so I know I have a frictional force here. So we will label that as the friction. The vector quantity, and that's going to be the 144 onto the 54, and that's equal to, we don't know that right now. Alright, so I'll do away with the question sign, just leave it just like that. Now all you have to do at this point is summation of forces in the x direction. I'm letting anything that goes this way be x, must equal to mass times the acceleration in the x direction. I will get 392 minus the force of friction, and again I'm not going to write all the symbols, just let it like that, is equal to the mass of the system, which is 54, times the acceleration, which is 5. Oops, I don't need the equal sign, sorry. Okay, so 54 times 5, write that better, sorry. That gives me 270. That gives me 392 minus the friction. Scroll down a little bit. We will solve, and the frictional force would equal to 270 minus 392. But they're both negatives, so my frictional force would be 122 newtons. Alright, so now we know that frictional force, especially when you have kinetic friction, is going to be the normal force times mu. Sorry, my arrows are not the best in the world. So I put the frictional force of 122. My normal force was 529.72. Times mu. So mu would equal to 122 divided by 5 29.72. Do that real quick. 122 divided by 529.72. That gives you a value of about 0.2303. Alright, that's how you get the frictional force there. Let's see, was there a part 2 to this real quick? Let me just go up for I think there was a part 2 to this. Let's do the part 2. The second part, which I did not list here, was I think it was a question we assigned to question number 9, was find the acceleration of the 144 kilogram. Alright, so let's just scroll down here. To do number 9, to find the acceleration of the 144 kilogram object. Then all you're going to do again is draw your force diagram or your Freebody diagram. You have a force coming down here. You'll have a force coming down this way. You'll have a force here. Now I'll talk a little bit about this one, but let's just go ahead and label these. I'm not going to run the calculations here, but the force of gravity of the Earth onto the 144, which equal to 144 times 9.8. Now you will also have another force coming down here, which is the force pair of this one here. So we have 529.74. Okay. Now the force of normal is going to be just the sum of these two. Now the reason I'm not going to take the time to calculate this is because I have no coefficient of friction here. So it's not really necessarily going to help me solve the problem. Feel free to do it. I mean, because the summation of forces in the y direction has to be equal to 0. So now here, this value here has to be 122 newtons. Because I have a force pair, and I'll label that. I have a force pair here. If the friction that this object here is pushing the 144 is going back, then this object will push 122 going back the other way here. So that's a force pair here and here. So now to find the acceleration, this problem is really easy. Just summation of forces in the x is equal to mass times acceleration in the x. I will get 122 is equal to the mass, and the mass was 144 times my acceleration of x. Solve for acceleration of x, and it'll just be 122 divided by 144. So 122 divided by 144 gives you a value of 0.8472. Okay, so that's how you do the first two problems. Okay, not too bad. Again, the most important thing is identifying your force pairs. Let's go to another one. Here you have 3 blocks. Get a pen. They're 3 blocks in contact each other, pushed across with 110. The coefficient kinetic friction between each block surface 0.29. Find the magnitude of the force exerted on the 8 by the 2.2. So we want to find this one here. Alright, what I would recommend with this problem first would be to treat this whole thing as one system. Again, you don't have to, but this is going to be the easiest for you. And find the acceleration first. Now you know the force is 110, so we'll write this as 110 Newton here. So can I not say that the summation of forces in the x direction of the system must equal to the mass of the system times the acceleration in the x direction of the system? So we have 110 newtons being pushed. Now you have friction, so let's talk about this. Isn't the total mass of the system would be adding all these together, which is going to give me 2 plus 8.8 plus 2.7. That gives me 13.5 kilograms. Now, if I drew the Freebody diagram of the system itself, here I would have force of gravity of the Earth onto the system would equal to 13.5 times 9.8. Now notice on the University text they changed the acceleration often between 9.8 and 9.81. That gives me 132.3 newtons. Now my force normal would also equal to 132.3 newtons because this object's not accelerating in the y direction. We know that friction is always going to be normal times mu, so we'll take this value here, we'll multiply it by the frictional coefficient. Gives me a frictional force of 10.45. I'll say 10.452. Now I have 110 pushing this way here. So all you have to do here is sum the forces. Sum the forces in the x. Set equal to mass times acceleration. I'll get minus 10.452 plus 110 is equal to 13.5 times my acceleration on the x direction. So minus 110, and then we divide by 13.5. That gives me acceleration in the x direction of the system, or of each block, of 7.37374 meters per second squared. Okay, so now we have the acceleration of the system. If I want to find the interaction force between here, I'm just going to draw a force diagram or Freebody diagram of the 2.2. I'll show you why this is simpler. Again, you don't have to do that, but it makes your life so much easier. I'm going to erase this 110 here. Alright, so if I do the Freebody diagram, we'll do it right over here. I have force coming down. I'll have my normal force coming back up. I'll have force coming this way. Friction coming back this way here. And off to the side, I'm going to put my mass times acceleration here. Alright, so let's just start labeling everything. This would be the force of gravity. And again, that would be the Earth on the 2.7. So 2.7 times 9.8 gives me a value of 26.46. My normal force would equal to 26.46 also. My frictional force is going to be this value times 0.079. Gives me a value of 2.090. Now this is going to be the force that the 8.8 is pushing on the 2.7, and this is going to be your mass times acceleration. Again, this is not part of the force diagram. I just like to put it off to the side, and we know what the acceleration is. Okay, now all we have to do at this point is sum forces in the x. Sum forces in the x, set it equal to mass times acceleration in the x. I will get minus 2.090 plus the force, the 8.8 onto the 2.7, must equal to 2.7 times 7.374. Okay, run those numbers. Solve the force of the 8.8 onto the 2.7 is equal to, and it becomes positive, so we add that. Gives me a value of about 22 newtons, 21.998. So we'll say 22 2 newtons. And that's it. That's all you have to do. Again, I treated this whole thing as a system. Again, you don't have to do that. You can go through the detailed work, draw force diagrams or Freebody diagrams of each one of these and work your acceleration that way. You'll get the same value. It's just a simpler approach.